G'day viewers. In this segment we'll talk about games you can play with IP prefixes. So our topic is really routing and how to help it scale. And we're going to take another look at IP prefixes. We looked at them before. Now we'll see how we can dynamically adjust the size of IP prefixes by combining them together sometimes. This is called aggregation. And by splitting them up at other times. This is called subnetting. So before I dive into those techniques, let's just go over some of the basics of prefixes that we learned. So we learned that IP addresses are allocated in these blocks. That's what an IP prefix is called. And we write them like this. 18.31.00/16 would be an example. And all of the hosts on one network share the same prefix. They belong to that prefix. A prefix is often written as a /n, where n some number, /16 in this example above. That means that the first n bits are fixed in the addresses, so all addresses inside that prefix have the same first n bits. Now, since an IPv4 address is 32 bits long, the remaining 32 minus n bits are free, and that means that there are 2 to the 32 minus n addresses inside that prefix. For instance, a /24 is going to have 8 free bits at the end, which is 256 addresses. Routers keep track of the length of the different prefixes. So simply by looking at an address, you can't tell what prefix it's inside. It's the router that has information about the length of the prefix. And the router uses this information as part of its longest matching prefix algorithm to forward packets in the right direction. Okay, so hopefully all of that rang a bell. There's one observation I want to make here, and that's that given this split and the fact that the prefix is not encoded in the address, routers can actually change the lengths of prefixes just to suit their own needs in ways which will help routing scale without affecting any of the hosts. This is the flexibility that we're going to leverage here. So let's move on now towards subnets and aggregation. And I'd like to talk just for a moment about prefixes and hierarchy. You might wonder what IP prefixes have to do with hierarchical techniques and scaling routing. Well, we've already seen it in one way. Simply using a prefix is a block of addresses. That's a little bit of hierarchy right there. But what I want to point out now is that we can go further and use the flexibility of prefixes a little more than we are. And that will get us to aggregation and subnets. In particular, we can use what's called a less specific prefix, a larger prefix, so it will have a smaller n in the /n, so it contains more addresses. We can use that as a name for a large region of the network. For instance, in this figure below, I might have 3 /18 prefixes, IP1, IP2, and IP3 inside my network. They're the actual prefixes that have been assigned to the different networks and for all the hosts on those networks. In some sense, that's what the network is. However, if the circumstances are right, what I can do inside the network is refer to all of these 3 prefixes by the one larger enclosing prefix, a /16. This is a less specific prefix. A /16 actually has room for 4 /18, so we won't always be able to use a larger prefix to name a region in which everything in which all of these prefixes reside. For instance, that other /18, we better make sure it's not somewhere else in the network. But if the conditions are right, we'll be able to use a less specific address like this /16 elsewhere in the network to represent all of the 3 prefixes in every host within this region. This is how we're going to use prefixes to get a little more hierarchy. The 2 ways we'll use this flexibility of prefixes are really 2 different use cases for adjusting the length of prefixes. Both of them are going to have the effect of reducing the routing table size by allowing parties further away to store not a set of prefixes, but a smaller number of larger prefixes, or prefixes which have smaller /n so they contain more hosts. The 2 techniques we'll look at are subnets and aggregation. They're really the same mechanism, they're just different perspectives on it depending on the party. So in subnets, when we have an address, we're going to internally split one prefix into multiple smaller prefixes. With aggregation, when inside, if our network we have several prefixes, we're going to join these smaller prefixes into one large address that we can announce externally. So let's see those ideas in a little more detail. Here's a subnetting picture. Now this is I've drawn a dotted line here on this router, which is the border router between here, it's some company, and the rest of the internet. Could be an ISP, most likely it's a company or an enterprise. Actually it looks like a university here. Outside this region, there is simply one prefix, this prefix here, which is advertised to the rest of the internet. It's a /16, so there are 32,000 odd addresses in it. This is the prefix the internet knows. We would have gotten that address as a university from IANA, the Internet Allocation Body, or from an ISP if you're a company. That's the prefix you got. Now you'd like to add some structure to your internal network. So what you can do is you can break this prefix up into different subnets. Each of these is a subnet. So I'm going to write subnet. They can be of different size just by playing around with the prefixes for unequal allocations. You can see there are 16,000 machines in the E department, 8,000 in the CS department, and 4,000 in the Art department. We can then use these different prefixes for our internal routing, and as long as we configure this border router correctly, we'll still only send the larger prefix for external routing. This is useful because an ISP or IANA might be willing to give a company one prefix, but not want to give it multiple different prefixes. So rather than having to get multiple different prefixes somehow, we can put the one we have to better use by dividing it internally to fit our needs. Here's aggregation. This is really the flip side of it. It's the same thing in reverse. Maybe you're here's again our border point, and maybe you're an ISP on the right, and you're talking to the rest of the internet over here on the left. Well, inside your ISP, you might have allocated 3 different prefixes here for different universities, for Cambridge, Oxford, and Edinburgh. Now, they all have different prefixes, they're different organizations, they asked for and received a prefix to set up all of their hosts, and they're running their networks independently. However, if all of these addresses are allocated from the right range, what you can do inside your ISP is aggregate them into one larger prefix, that's the one here, which has been advertised to the rest of the internet. The rest of the internet will then route to that prefix, and it's only when we get inside the ISP that we'll need to distinguish between different parts of it. In both of these examples, I'll leave it to you to work through all of the different bit masks and see that in fact these addresses have been divided into more specific prefixes or aggregated into less specific prefixes correctly, and that all of the bits work out. But that, in a nutshell, is how subnets and aggregation work.